Right, hello, welcome. This is the AQA A2 Unit 4 multiple choice paper. Now, because this is the first paper of the A2s that I'll be doing, okay, I just thought I'd give you a bit of an overview of how the papers are going to be laid out, because obviously you might not be able to bother to look at the plates, but I think it's quite self-explanatory. Anyway, so in Unit 4, as you know, we have a multiple choice paper and a written paper, okay? So they'll be split. They'll be split into their own playlists. So generally there'll be like a playlist, one video in it. So don't be put off if you do see that. Okay, so I'll have a playlist for Unit 4. Okay, Section A, Unit 4, Section A, and then a playlist for Unit 4, Section B. Okay, now they won't be just jumbled up. They will be as I say, they will be the individual videos, okay? So you'll have a playlist with one video in it, but that's just to help split it up, okay? So you'll have two playlists for each year. And then obviously for the Unit 5 side of things, and get on to recording them videos, obviously with Unit 5 we have the thermal and the astrophysics. Now again, because they're two separate papers, okay, because I can acknowledge that people will be doing, not everybody will be doing astrophysics that watches this, so I do apologise if you don't, but I can't really do a paper I haven't done some work on, okay, so obviously I can't do medical physics. I could have a go, by all means, but I mean it'd be a waste of my time, because I wouldn't know what I'm doing. Part of this is for me learning the stuff as well, you might be worried to hear, but as I say, I don't think it's worth me going through the other unit papers, okay? So I'm going to leave that one if that's alright. But I will do a specification overview if you do want me to for the other option units. But as I say, for Unit 5 there is the thermal physics, which I will be doing. Obviously, that everyone does that, so I'll definitely be doing that. And also I'll be doing the astrophysics, okay? So there's two separate papers, okay, so in total for each year you will have 4 playlists, okay. Now whether I put them up as a single playlist, so June 2015 I'll put every single video for June 2015 in there, or I might just do a single playlist for I might do one video a playlist, or I don't know how I can get up. I'll probably put all of June 2015 papers into one playlist and have them separate videos. Anyway, okay, so that's wasted too much time already. So, well done if you've skipped to this point, okay. This is obviously the start of the multiple choice. Now, with multiple choice, it's very key in terms of it's like answering a question, and it's just answering the question as though the multiple choice wasn't there, okay, for the calculation ones. But obviously, for the ones like how it starts, just a case of deduction, okay. Now, this is quite a common question they like to ask, which is about relating the rate of change of momentum to the resultant force, because some students will forget that. They will think, momentum is such an easy topic, why do I bother needing to revise it? Well, it's things like this, okay. So the question says for question 1, which of the following has the same unit as a rate of change of momentum? Now let's just think of what the rate of, before we read off what the answers are, okay, potential answers, okay, so rate of change of momentum. Well, the rate of change of momentum is a change of momentum over time. In other words, that's equal to the resultant force, and I showed you how that was, I think, on a separate video that I've got to upload yet. But anyway, the rate of change of momentum is the resultant force. And therefore, you could go, we'll try and work out what the units of this are specifically. So we could say the change of momentum is kilograms, okay, metre per second, and time is obviously measured in seconds, so it's kilogram metre per second squared. Now you could do that and see what you get for that. However, it's easier just to go off the fact that this is equal to a resultant force. Anything that's equal to a force can be measured in newtons. So therefore, obviously, if you just use the standard thing of working out what the units of that were, you could say the units are either kilogram metre per second squared, or you could go off the fact that all forces are measured in newtons. You could say it's either measured in newtons or that. But let's see what we've got here listed. Now, as I say, it needs to be a force, because this is equal to a force, so therefore that must be equal to a force as well. These are just units for force. Obviously you've got other ones as well, but I didn't list every one. So basically what we're looking for here is an answer which is a force. Now it'd be really helpful, and we'll see as we go through, that there would be only one answer which is a type of force. Okay, so 1A, work. Well, obviously that's relating to work done, okay, which technically is a force, but it's not really a strong contender. I wouldn't really be looking at that and going, that's definitely it. Energy. Well, energy is not a force, okay? This is just a measure of something, okay? Energy is not a force, so it's definitely not B. C, acceleration. Well, the resultant force equals mass times acceleration, so therefore acceleration is not force, okay? It's what determines the resultant force, yes, but it's not the force. And you have to remember the units of energy are joules. That's not equal to any unit of force, okay? And the units of acceleration are meters per second squared, which is in there, but it's not on its own, okay? So it's not acceleration. Weight, that definitely seems like the right one, okay? Because weight is a force, and that is a force. Now, granted it's not in kilogram meters per second, but that's a unit of force, okay? Everything that's every equation that's got F equals it, in other words, every equation for force, whatever equation that is, whatever units you get by just using standard indices kind of thing for working out the units, it's very easy just to say that's also a unit of force. And well, I say for this one, rate of change, it's a rate, they wouldn't have mentioned the rate of change of momentum if you didn't have to use it, okay? Now, as I say, none of them have units of kilogram meters per second squared, so that's why maybe you're looking at that going, what the hell? Because weights, well, that's measured in newtons, okay? So therefore, none of them seem to be right, but remember that's equal to the resultant force, so therefore you would say it is D, the weight. Now, granted you go, well, why isn't it A? That's work. Well, specifically it doesn't say work done, so you can't really invent something that isn't there. And to be honest, weight seems, I mean, it's a 50-50 chance, really. I can't do any better explanation than that, so hopefully that's good enough. So, for one, it's D. Okay? Right. Okay, so the next one I think helps to draw a diagram. Now this is why I don't like multiple choice, because you really don't get enough room at all. Okay, I personally think we should provide you some kind of answer, but anyway. Right, okay, so it says the nucleus of a radioactive isotope X is at rest and decays by emitting an alpha particle, so that the new nuclide Y is formed. Which one of the following statements about the decay is correct? Okay, so we've got a few listed here. A, the momentum of Y is equal and opposite to the alpha particle. B, the momentum of Y is equal to the momentum of X. So obviously if A is right, then B is wrong. Well, obviously one of them is going to be right. So, but A and B are related, okay, because either A is right or B is right or neither, okay, which is kind of saying everything, but anyway. C, the kinetic energy of Y is equal to the kinetic energy of the alpha particle. D, the total kinetic energy is the same before and after the decay. So what it's trying to confuse you here, as I say, some teachers go, oh, they don't try and trip you up on questions. Well, quite clearly this one is. And that's because it's, I think personally, it's trying to confuse you between conservation of momentum and the conservation of energy. Kinetic energy, to be precise. There's no law that says kinetic energy is conserved, unless it says the collision is elastic, but it doesn't mention any of that in here, okay? So I highly doubt, just off saying that, I highly doubt it's going to be something to do with the kinetic energy, okay? But then again, it could be, okay? What I'm saying there is definitely not D, because it's not mentioning anything about elastic collision, so it's definitely not D. So therefore it's either A, B or C. And to narrow it down, because really I could try and talk you through it, but I think it's better to kind of do sign language to the camera. Well, no, obviously not, but I think it's better to do a diagram, okay? And the diagram I drew was, well, initially somewhere on your page just have the X particle, isotope, okay? And we know it's going to decay by emitting an alpha particle. Okay, so therefore it must, you can think of this as like an explosion. I've already given the hint as to do the momentum there, but anyway. So the alpha particle's been pushed that way. So initially this had, let's work out the momentum of this. Well, it wasn't moving. It says it's at rest. It wouldn't have mentioned at rest if we didn't have to use that information. So we know it's got a mass of whatever it has, doesn't really matter, irrelevant considering the velocity is 0, okay? Now we don't have to work out the velocity of the alpha particle, but we know it's going to, we'll just take the direction of the alpha particle to have a positive direction, a positive meter per second. Okay? And obviously the mass, well, again, you could work it out, but we're not interested in it. Okay? Because it's not mentioning about the mass, and we're not looking at kinetic energy. Well, especially not D anyway. So, because I've kind of mentioned it's an explosion, okay, we need to conserve momentum, okay, that's just a law, okay, because when an isotope decays, and this is generally quite, again, a sort of common question, but again, they word it slightly different ways so it doesn't look like the same question. But remember, the conservation momentum says the momentum before has to equal the momentum afterwards. So, I mean, hopefully I've given enough information to say it's not C, okay? Because, well, it could be C, as I say, but we don't know the velocities of the two particles, and there's no possible way to work it out, so we can't say that is correct. It could be correct, but we need a bit more than could be, okay? So, because they've not told us the velocities, you can't put C. Now, as I say, C looks right, and it could well be right, but we don't know the velocities. I doubt it's right because Y is going to be, well, I just doubt it's right, but we don't know it's right anyway because we're not given the velocity, so you can't assume that. So therefore it's either A or B, and A or B is talking about the momentum, okay? In other words, the conservation of momentum. Now, as I said, the conservation momentum says that the momentum before the collision or whatever has to be the same as the momentum afterwards. Okay? Now, we said, so let's work out, so the momentum before, quite clearly, it doesn't matter what mass this X particle has, its momentum is going to be 0, because obviously anything times 0 is 0. Good maths. And as I say, we're taking out the direction of the as positive because it's going to have to go in a direction, and with all momentum calculations, you always take the initial direction as positive. Now, I only put the alpha as having a positive direction because it was mentioned first. There's no other reason. You could have put the alpha particle as having a negative velocity there. I just put it as a positive because it was mentioned first, because I'm lazy. Okay, so let's just think, is it A? Okay, actually no, we'll go with A. The momentum of Y is equal and opposite to the momentum of the alpha particle. Well, it's for equal and opposite is the key word there, okay? If it's opposite, in other words, obviously it can't have an opposite mass, there's no such thing as that. Well, technically there is, but that's not going to be asked in this situation. What it's talking about is the velocity, okay? Now we know velocity is the speed in a given direction, so therefore this nuclide Y, it doesn't matter, has the same momentum, okay, we're told that, but it has a negative velocity, so its mass will be whatever, okay, and its velocity will be a negative. And obviously it might be a different speed to the alpha particle because it has a different mass, okay? It's probably going to have a different speed, but the fact that its momentum is the same but opposite means if you were to add these two together, okay, it's one momentum that's positive, take away the same momentum, okay, because these two had the same momentum, then the overall momentum should be the same as the start, which is 0, okay, so it's looking like it could be A. And it definitely is, but let's just look at B, so we're doubly making sure. B says the momentum of Y is equal to the momentum of X. Now, if that's true, okay, what it's saying there is the momentum of Y is going in the same direction as A, okay? It's got the same momentum, the mass is whatever, but it also has a positive speed, okay? Now that's completely wrong. I'll tell you why. As we mentioned, the total momentum before was 0. That's because obviously the velocity was 0. Now if we add these two together, we're adding a positive and a positive. Well, that's going to add to a positive. Now it doesn't matter what the number is. It's quite clearly not going to be 0, okay? Otherwise that would have to be negative, and that would have to be going that way, and that's what it says in part in suggested answer A. Okay, so obviously it's going to be A. So the answer to question 2 is A. Alright, so hopefully that makes sense. Right. Again, the question 3 is about the conservation of momentum. Generally, in Unit 4, the first few questions are, because I mean it's such an easy topic, and there's only so much they can ask, and it can only ask about the kinetic energy, the rate of change of momentum, and the elastic or inelastic collision. They can't really ask anything else. There's not, or work out a change of momentum or something. There's, as I say, there's nothing more really they can ask us in. Well, and this proves the fact that it makes me think why they did actually put it as an AS topic in the linear course. Okay, so anyway, right, so we've got these 2 trolleys. Okay, now because it's a multiple choice, I just want to get it out of the way. In terms of, I don't want to keep pause it every video, every question, because I think you might get a little bit bored of me keep pausing it. Okay, so right, okay, so we've got 2 trolleys here. Trolley 1 has a mass of 2 kilograms, and they both have a mass of 2 kilograms actually, but this trolley 1, okay, is initially moving towards the other 2 kilogram trolley, which is at rest, okay, which obviously, as I say, also is 2 kilograms, is moving towards the other 2 kilogram trolley, okay, which we label as T2, but this one is at rest. In other words, this is moving at 0 meters per second. So that's quite a good thing to, I mean, I'm sure you know that anyway, but just make sure you know that at rest just means 0 meters per second. Okay, so the key word in this question, it's actually put it as a separate sentence on its own, which is quite nice. It tells us that the collision is elastic. And that's crucial to helping us work out this question. The collision is elastic. That allows us to work out what answer we're going to choose. Now, as I say, the elastic and inelastic is to do with kinetic energy. Now, the elastic one suggests there is no loss of kinetic energy, whereas inelastic, there is loss of kinetic energy. Okay? So therefore, straight away, we're not just going to be, we know momentum is going to be conserved, and it's likely in every answer they give, because what we're asked to do here is work out which of the following statements is correct, and each statement just gives a potential outcome after the collision. Okay, now the fact that, as I say, the collision is elastic means there's no loss of kinetic energy, but the fact it's very likely one of them answers are all probably going to conserve momentum. Okay. Some might, some won't, but it's likely they all will. Okay, so hopefully, if you did think that was to do with momentum is conserved, you complete clot, because you should always realise it is always conserved, apart from obviously when you have an outside force, but there's no such on here. Okay, so ideally, what we need to do is work out the total kinetic energy before, and in each of the answers, see which one gives the same kinetic energy. Now, there's only going to be one of these situations out of the 4, A, B, C, and D, that gives the same kinetic energy as the combined of these 2 before. Now, quite clearly, there's no point working out the kinetic energy of T2, but it's nice to show it. Okay, so as I say, you don't get marks for showing you working in multiple choice. Okay, and to be honest, they're only worth 1 mark each, so it's unbelievable the amount of work you have to do for 1 mark. But anyway, so you don't obviously need to state, you know, what every bit you working out. You just need to know in your head that means the kinetic energy is conserved. Okay, so therefore you would just do a little calculation at the side. Okay, so it doesn't have to be neat. Just work out you don't even need to include this and show you including that new calculation, okay? Because you know that's going to equal 0 kinetic energy. So you know kinetic energy before, okay, is a half of mv squared, half times 2 times 4 squared, which is obviously the same as doing 1 times 4 squared, which is obviously 16. So kinetic energy before is 16 joules. Okay, now as I mentioned, just before I go on to all the answers, there's one more thing I want to point out. As I say, elastic. When a collision is elastic, that means the kinetic energy is conserved. So, sorry, yeah. When a collision is elastic, kinetic energy is conserved. But when it's inelastic, then obviously it's not conserved. Okay. So there's one more thing. Yeah. Inelastic collision, you have something called a totally inelastic collision, which is still where kinetic energy is not conserved. However, the two objects move at the same speed. In other words, they move together. So therefore, if it is elastic, anything that is inelastic is going to be wrong. And if we quickly look through the answers, I know I shouldn't really be doing this, okay? We should go through A and see if that's right, B and see if that's right, C and see if that's right, etc, etc. But you can straight away spot C and D are about T1 and T2 both moving at whatever speed, they're either 2.8 or 1.4. So because I say that, because you are pressed for time, okay, there's no point working out the kinetic energy of C and D, because you know it's not going to be the same as this, because them two situations, okay, situation C and D, okay, both imply a totally inelastic collision. And we know the collision is elastic, we've been told that. So therefore, C and D are not going to be right, so you can cross C and D off, okay? So therefore, it's definitely out of A and B. So you only need to calculate the kinetic energy for A and B, okay? Now, remember, the key thing here is to remember that, again, velocity is a vector. So it has a positive and a negative direction. I think that's going to help us decide whether it's A or B. Now, A says, after the collision, T1 is at rest, so basically what happens, and T2 gets 4 meters per second, so basically what happens is all of its energy is transferred to T2, which then carries on at the same speed. And you don't need to be a genius to work out that's going to have the same kinetic energy, because if T1 is now at rest after the collision, then that's going to have a velocity of 0 meters per second, and it transfers all its energy to T2, which has a speed now of 4 meters per second. So basically it's a role reversal of this, okay? Where T1 is at rest and T2 has a speed of 4 meters per second. So quite clearly, and the only reason we can assume we can say that so quickly is because they both have the same mass. Now, if that wasn't the case, then you would obviously have to work out the kinetic energy. But as I say, it's multiple choice. You don't need to show you're working, because you don't get any marks for it anyway. So you might as well just say I've got it right. Okay, so hopefully you can see why it's A. However, it's just worth double checking that you are right. Okay, so as I say, velocity is vector. B says T1 will rebound from T2 at 4 meters per second. In other words, it will crash into T2 and then go back with the same velocity but in the opposite direction. So therefore, it will have a speed of minus 4 meters per second. That's a change of 8 meters per second, as you can quite clearly see, from positive 4 to negative 4. So therefore, you can see even in that situation, actually, momentum is not conserved. Or is it? No, it's not. Okay, so actually, sorry, try to my own foot there. Momentum is not conserved in that one. But anyway, you work out that, and obviously velocity is negative, so therefore it's not going to be B. Okay, so therefore it's going to be A. Now, as I say, you may be going, oh, why don't we just turn the velocity positive? Well, you can't really do that, and you go, well, if we put minus 4 therefore into the calculation, you utter idiot, we'll have minus 16 joules, and you can't have minus 16. Well, that is correct, but there is another answer which fits better, okay? And there's no other way of working out the total kinetic energy apart from taking it as a negative figure, otherwise A and B are right, and you will never have two answers that are completely correct. Okay, one will be more correct than the other. That's what generally happens in life with multiple choice. You'll have a couple of questions and a couple of answers, and two will seem correct. One will be more correcter than the other. Great English there. So as you can see, that's obviously answer A. So 3, for answer 3, it's part A. Just double check it was right there. Okay, so right. Okay, so that's question 3 out of the way. Sorry.